Alright, in the previous video there were some problems relating to the permissions and the user being added to the line printer group. So as you could see in the previous video, I have added the my user to the line printer mode, to the line printer group, and then restarted the system. So now it should work fine without any problem. Let's just reverse this back. Reverse this back. Start the multimeter. And now we will run this example. And so far we have we got an input here into this one. So this is 0, 1 at the end. So this basically the port written as this 0 B 1 1 2 3 1 2 3 4. This is the same as 80 in hex, right? Now let's see the spin. Where is this spin? I think this one. No, it's not. Say the bin that has the purple color. Oh yes. It should now be active, by the way. And it's not working. So let's take the bit 0 and try to activate it. First of all, let's check the bit 0. This is the those are the actual bits. This is the strobe control, and this one should be bit 0. And yes, we got it running now. It's active now, the actual bit 0. Okay, let's take the other bits. Let's activate the rest and see what is the behavior of this. Okay. And bit 5. Now we have this, the full data register is now on. Let's first test the rest of the pins before actually. And this is our pin. This is the second one, the third one. So let's start from the beginning. This is bit 1 or bit 0 at this stage. Bit 1, bit 2, and bit 3, bit 4, bit 5, bit 6, and bit 7. So this is the last pin, and it is actually active. We have been testing the wrong pin all this time. So this is not the purple one. This is actually a white one. So this is a white pin, the last pin. All right. So let's run this again. And now we have FF, which is the 255, the max for the 8-bit. Now let's go over backward. Bit 7, bit 6, and bit 5, bit 4, bit 3, bit 2, bit 1, and bit 0, and then the control bit 0. This is the control bit 0, which is the in strobe. It's an active low bit. So if we actually change this to off, for example, let's just change it to off. It's in the active. This is a host control pin. So this initiates the communication between the host and the peripheral in the negotiation modes. It's not used anyway. And you could see that it's now active because it is active load. It is an inverter pin. It is an inverter bit, all right? So I guess this concludes the hands-on showcase, just a proof of concept showcase. The point that you could build your application over this, and there is an actual GenAI layer API that you could use to port this code to the job applications. The GenAI layer is provided here by the electrostatic 4J, the electrostatic core, and it actually utilizes the JSNAP loader library, which extracts and loads the native library. But anyway, it's just a placeholder. It contains just a native image loader utility, and there are no anything. If you want to implement this, you can fork, clone, and do your own magic with this. Now, the vision is to use to attach modules here to this data registers, to this data and control registers. And for example, you could actually multiply these ports either using a shift register, a universal shift register, which presents the data in serial in to parallel out, or parallel in to serial out, right? This one of the good interfaces that you could use, and that could provide you up to 8 power X of the of GPIO ports controlled using the serial clock, right? So you have to actually think of the design to utilize the actual control bits for the clock of the serial clock for the shift registers network that you will use. So this is a design convention. There is another design convention though, is to use multiplexers. Well, in this case, it will be a demultiplexers that actually decode the signal from the GPIO pin into a network of output. So there are two design conventions here, and I will try to examine both in the future, in the near future. But hopefully this will give you insight about how things work and how development actually is moving forward in the ElectroKIO project. This will be the first thing to implement. Although the RS-232 is already implemented in the Serial 4J project, but the Serial 4J is not actually a part of the ElectroKIO for now. So we have to re-implement the RS-232, in a way that is similar to this library. So it should be way similar to this library that conveys a physical model and an application level model, as I have showed you in the previous video. So this concludes the video, and thanks for watching. You could always you could always think of trying the ElectroKIO Sandbox SDK, and if you have tried it, just let me know. If you stepped in any problem, you could use the tutorials on the playlist to get it started. If you find any problem, you can direct message me, and hopefully the ElectroKIO Sandbox SDK will actually serve its purpose. I hope so.